So we're going to pick up where we left off yesterday. We were adding, subtracting, multiplying, and dividing. We looked at rationalizing a little bit yesterday, but we're going to continue on. We've rationalized single radicals, right? And so how do you rationalize a single radical? You multiply by that radical in the top and the bottom of the fraction, in the numerator and the denominator of the fraction. But how do you rationalize with binomials? And that's what's a little bit different, okay? So that's what we're going to look at first thing today. Hold that thought. Okay. So let's just review a couple of definitions first. You've already had this one definition. It won't hurt you to write it down twice just to have it in the notes, but let me remind you, to rationalize a denominator means it is the process of eliminating a radical from the denominator. You cannot have a radical in your final answer of a denominator. It is just not proper, okay? I added a part to it today. Binomials, in the form of, normally you have a radical plus a radical, a times the square root of b plus c times the square root of, excuse me, this should be d, typo. Let's make that a d and make this a d. I'll have to fix that. And a times the square root of b minus c times the square root of d, they are conjugates of each other. So in order to rationalize a denominator of a binomial, you have to multiply by the conjugate, okay? So I know the a times the square root of b plus c times the square root of d, that's the variable definition. Let's look at it in reality. If I have 3 plus the square root of 5 in a denominator, what would the conjugate of 3 plus the square root of 5 be? Three minus the square root of 5. Yeah, it's the same thing. Notice variable form. It's the same thing. It's just, and they don't completely change signs. It's just if you're adding one, you just subtract the other, okay? The conjugate. What if I have the square root of 2 minus 7 in a denominator? What would I multiply by? What would the conjugate be? Square root of 2 plus 7. Okay, that's the conjugate. Okay. Again, they're not complete opposites. You don't change the sign of the first one. It's just if one is adding it, then the conjugate subtracts it. If one is subtracting it, then the conjugate adds it. Okay. If I had 2 times the square root of 3 plus 7 times the square root of 6, what would the conjugate be? Two times square root of 3 minus 7 times square root of 6. Okay, that's the conjugate. One more. What if I had negative 8 plus the square root of 5? What would the conjugate be? 8 minus the square root of 5? Negative 8 minus the square root of 5. Again, the first part doesn't change. Okay? The first part doesn't change. It's just if one of them is adding, the other one subtracts. So if it's negative 8 plus the square root of 5, then the conjugate would be negative 8 minus the square root of 5. Okay, any questions on what we're going to be multiplying by in order to rationalize? Okay, so keyword definition here is conjugate. All right, now let's look at an example. We'll make this example 1. First of all, if you can simplify anything, you would try to. Can anything be simplified? No. So does that mean we're done? We can leave it as is? No. What's the issue? We have a radical in the denominator. And the difference today is that it's a binomial. Okay, the difference today is that it's a binomial. So in order to rationalize it, you have to multiply by the conjugate. Okay, the conjugate of the square root of 5 minus 1 is square root of 5 plus 1. And if you multiply that by in the denominator, you must multiply by it in the numerator. Okay, so these are binomials. How do I multiply 2 times square root of 5 plus 1? Distribute. So 2 times square root of 5 is 2 times square root of 5. And 2 times 1 is 2. Very good. Divided by, how are we going to multiply 2 binomials? FOIL. So here we go. Square root of 5 times square root of 5. 5. Square root of 25, which is just 5. Okay? What do you know? We talked about this in third block yesterday. We noticed that this is they're the same thing, but different signs. That's the difference of 2 squares, right? And we talked about if you recognize that, what do you know about the outer and the inner? They're going to cancel. So the question was yesterday in third block, do we have to do all that? No. As advanced students, if you realize, if you need to, you can do square root of 5 times 1 and negative 1 times square root of 5. But they will be opposites of each other, and they will cancel out, so you don't need to worry about the outer and the inner. And that's going to make your math go a lot quicker on these, okay? Will the outer and the inner always cancel? Yes, and you know why? That way it gets rid of the radical in the denominator. That's how it's a part of rationalizing, okay? So then all you got to do is the last part. Negative 1 times 1 is negative 1. So we can combine that. So 2 times the square root of 5 plus 2 over 4. Now the question is, are we finished? Okay, so can I just go ba-bam, ba-bam? No. The only time I would simplify these is if both this is being divided by 4 and this is being divided by 4, and they both can be divisible by 2, so then you can simplify it. Another way, and we'll look at some that can and can't simplify, but another way that I would look at this is, what can we factor out of the numerator? If I factored the numerator, what could come out? A 2. And so if I take a 2 to the outside, what would I be left with? Square root of 5 plus 1 over 4. Now, because these are both on the outsides, we can simplify them. This can become a 1, and that can become a 2. So what's my final answer? Square root of 5 plus 1 over 2. There's your final answer. So if something can factor out, you need to factor it out and simplify further. Okay? What if, just talking, what if you had, I don't know, I'm trying to think, 2 times the square root of 5 plus 7 over 4. Could you simplify and make that a 1 and make that a 2 and make it square root of 5 plus 7 over 2? Why not? Because both of them did not. If you're going to simplify it, does that make sense? So I would go the factoring way. I would factor stuff out because if it comes out from both and it goes to the outside, then it can. But you can't just look at ba-bam, ba-bam and start factoring stuff. I agree. That's protected within a binomial. Okay? All right. Can anything be simplified? Not yet. So what do we need to do? What's the thingy called? We got to multiply by the conjugate, and that is called the process of rationalizing. I need you to understand what the words are. We need to rationalize, Ms. Corns. We need to get that square root out of the denominator. So, what are we going to multiply by? We're going to multiply by the conjugate. What's the conjugate of square root of 2 minus 3? Square root of 2 plus 3. So, I'm going to let you take it from here. How are you going to multiply all these binomials? FOIL. So, I'm going to let you go as far as you can. Here we go. We're going to FOIL this. So, 4 times the square root of 2 is 4 times square root of 2. 4 times 3, 12. Square root of 2 times square root of 2. Just 2, right? Square root of 2 times 3. 3 times square root of 2. Whoa. All right. On the bottom, square root of 2 times square root of 2. 2. What do we know about the outer and the inner? They will cancel. So then when you do the last, negative 3 times 3, negative 9. Yeah, these aren't radicals, so you actually have to multiply the 3 and 3. Okay? So we combine like terms. Up top, 4 times square root of 2 and 3 times square root of 2 is 7 times square root of 2. And 12 and 2 is 14 over negative 7. How many got that far with it? If you didn't, can I help, or do you have questions? Do you know where you went wrong? All right, so from here, am I finished? No. What can factor out of the top? A 7. So if we take a 7 out of the top, we would be left with square root of 2 plus 2 over negative 7. And so what would my final answer be? If the 7's cancel, square root of 2 plus 2, what about that negative? So negative square root of 2 plus 2, like so. You need parentheses, because technically, if you're going to put it without parentheses, what does that negative go to? It goes to the square root of 2, and it goes, I will accept this, or I will accept that. Does that make sense? But if it's a binomial, you got to put the parentheses around it, because that negative, technically, if you just put negative square root of 2 plus 2, then I think the negative's just going to the square root of 2, but it's actually going to both. Do you understand? So either you take it to both and show me that you know that it goes to both, or you put a set of parentheses and put the negative in front. Okay, how many got it? Nobody? How many got super close? Oh, okay. All right, you try this one then. This is the last one on our notes, and then I'm going to get you up at the boards practicing. All right, so let's see if we did any better. The conjugate of square root of 3 plus 4 is square root of 3 minus 4. How many were able to get the conjugate correct? All right, so part 1, we're there. If you can give me the conjugate correct, we're halfway there. All right, then we need to FOIL it. So let's see what we have. 6 times the square root of 3. 6 times square root of 3. 6 times negative 4. Negative 24. Negative square root of 3 times square root of 3. negative 3. Okay. Again, is everybody able to just say 3? Does anybody need to say square root of 9? If you need to, that's fine. Negative square root of 3 times negative 4. Positive 4 times square root of 3. Over square root of 3 times square root of 3 is 3. We know the outer and the inner cancel. And then the last 4 times negative 4 is negative 16. How many have it so far? Getting better. Very good. So let's combine like terms. 6 times the square root of 3 and 4 times the square root of 3 is 10 times the square root of 3. Negative 24 and negative 3 is negative over negative. The question is, are you finished? Can anything factor out? No. So you are done. Okay, you are done. Did you get all the 4 pieces? So from here, I just combine like terms. The 6, be quiet please. The 6 times the square root of 3 and the 4 times the square root of 3, they match. You just add them. And you get 10 times square root of 3. And then same thing here, the two middles, negative 24, negative 3, match. So you can add those. Okay? If they have like radicals, you can match them. All right. Let's do some practice.